Mars, the enigmatic red planet, has fascinated humanity for centuries. In recent years, the mysteries surrounding Mars have deepened as advancements in space exploration and technology have provided new insights into its history and environment. From its Earth-like past to the puzzling evidence of potential ancient civilizations, Mars is strikingly similar to Earth in many ways, yet fundamentally different. With a diameter about half that of Earth and a surface area nearly equivalent to Earth's total landmass, Mars offers a familiar yet alien landscape. Its gravity, however, is only 38% of Earth's, and its density is significantly lower, resulting in a planet with just 11% of Earth's mass. Despite these differences, Mars's geological and atmospheric history suggests that it was once a thriving, Earth-like world. Scientists have revealed that Mars once had a thick atmosphere, liquid water in the form of lakes, rivers, and oceans, and a climate warm enough to support life. The transition from a potentially habitable planet to the barren, desolate world we see today is one of the great mysteries of planetary science. Mars's transformation began billions of years ago when it lost its atmosphere. Researchers believe that massive magnetic tendrils once protected Mars, much like Earth's magnetic field shields our planet from solar winds. However, these magnetic rotations weakened over time, allowing solar winds to strip away Mars's atmosphere. This loss of protection caused the planet's surface water to evaporate and escape into space, leaving behind a dry, arid world. Although Mars lacks a global magnetic field today, evidence suggests that parts of its crust were once magnetized. Alternating polarity reversals in Mars's magnetic field hint at a dynamic core in the planet's distant past. Understanding this process remains a critical area of research, as it could reveal clues about the planet's evolution and its potential to host life. One of the most intriguing discoveries on Mars has been the detection of methane in its atmosphere. Methane is a potential biosignature, as 90% of the methane on Earth is produced by living organisms. NASA's Curiosity rover has recorded spikes in methane levels, sparking debates about whether this gas could be a sign of microbial life beneath the Martian surface, while geological processes such as serpentinization could also produce methane. The prospect of life on Mars remains a tantalizing possibility. If life does exist on Mars today, it is likely to be microbial and hidden underground, where it would be shielded from the planet's harsh radiation. This leads to the question, if Mars can still sustain life in some form, what might its past have looked like when conditions were far more hospitable? The idea that Mars once supported advanced civilizations may sound like science fiction, but some scientists and theorists believe there is evidence to support this claim. Dr. John Brandenburg, a plasma physicist, has proposed the controversial hypothesis that Mars was home to a Bronze Age civilization that was wiped out by a nuclear event. He points to data from regions such as Cydonia Mensae and Galaxias Chaos, where unusual landforms and patterns have sparked debate among researchers. NASA's Mars Reconnaissance Orbiter, MRO, has captured images of peculiar structures on the planet's surface. Some of these structures, analyzed by independent researchers, appear to have geometric patterns that suggest artificial origins. While many mainstream scientists attribute these features to natural processes, the possibility of ancient ruins continues to intrigue those searching for evidence of past civilizations. In the past decade, the Internet has been flooded with images from Mars, many of which have been meticulously analyzed by amateur alien hunters. Some of these images show shapes that resemble buildings, statues, or even machines. For instance, images from MRO reveal a region near the equator, known as Arabia Terra, where raised structures and unusual crater formations have fueled speculation about their origins. One striking example is the Cydonia region, home to the infamous Face on Mars. Initially captured by the Viking 1 orbiter in 1976, this face-like formation was later revealed to be a mesa. However, its uncanny resemblance to a human face continues to inspire discussions about the potential for intelligent design on Mars. One of the most intriguing claims about Mars comes from retired U.S. Army General Albert Stubblebine, who famously stated that there are structures and machines on Mars, both on and beneath its surface. According to Stubblebine, these artifacts are not visible in conventional imagery but can be detected with advanced imaging technologies. While his assertions have been met with skepticism, they add an element of intrigue to the ongoing exploration of Mars. Mars's surface is dotted with craters and landforms that defy easy explanation. One notable example is the raised relief appearance of certain secondary craters. These features, thought to result from high-speed ejecta during impact events, resemble bas-relief sculptures. NASA scientists hypothesize that fine-grained materials, such as dust or pyroclastics, may have hardened during these impacts, preserving the unusual formations. Other geological anomalies include hexagonal craters, ridges resembling channels, and sedimentary layers that hint at ancient water activity. Together, these features paint a picture of a dynamic and evolving planet, shaped by both internal forces and external impacts. Recent missions have provided tantalizing evidence of water beneath Mars's surface. In 2018, scientists, using data from the European Space Agency's Mars Express orbiter, detected a lake of liquid water buried beneath the planet's south polar ice cap. This discovery has profound implications for the search for life, as liquid water is a key ingredient for sustaining biological activity. Moreover, subsurface radar scans have revealed layered deposits and anomalies that could indicate the presence of frozen or briny water. These findings suggest that Mars's underground environment may hold clues to its past climate and habitability. NASA's rovers, including Curiosity and Perseverance, have been instrumental in unraveling the mysteries of Mars. Equipped with sophisticated instruments, these robotic explorers have analyzed rock samples, measured atmospheric gases, and captured stunning imagery. Perseverance, in particular, has focused on the Jezero crater, a former lakebed that may hold evidence of ancient microbial life. One of the rover's most exciting missions involves collecting samples for future return to Earth. These samples could provide definitive answers about Mars's geological history and its potential to support life. As technology advances, the exploration of Mars is poised to enter a new phase. Ambitious plans by NASA, SpaceX, and other organizations aim to send humans to the Red Planet within the next 2 decades. These missions will not only seek to establish a human presence on Mars, but also explore its resources, such as water ice, to support long-term habitation. The possibility of terraforming Mars, transforming its environment to make it more Earth-like, is another topic of interest. While this concept remains theoretical, it underscores humanity's enduring fascination with the Red Planet and its potential to serve as a second home. Mars serves as both a mirror and a mystery. Its similarities to Earth remind us of our planet's fragility and resilience, while its differences challenge us to expand our horizons. From the potential for microbial life to the possibility of ancient civilizations, Mars invites us to imagine a world beyond our own. As we continue to explore its surface and delve into its history, Mars remains a testament to the boundless curiosity that drives human innovation. Whether it holds the key to understanding life's origins or serves as humanity's next frontier, the Red Planet will undoubtedly continue to captivate and inspire for generations to come.